In this video, we will practice our basic integration skills. But before we get started, let's review with a quick mini lesson off to the side. For example, say if you took the integral of 6x squared dx. We can use the power rule of integration, and we would add 1 to the exponent here. So that would give us x to the third power. So at this moment we have 6x to the third power, but then part of the power rule is you then divide by the new exponent you just found. So we would divide by 3. We always have to put a plus c on the end of here for the constant of integration. And this is the answer. Of course, we could simplify this and write 2x to the third power plus c. When you integrate like this, the result is called an antiderivative. The meaning of that is this expression is something that if we were to take the derivative of it, it should get us back to the original function that we started with. So in fact, you can use that to check your answer. So if I wanted to take the derivative of the answer that we just found, we will then see what happens. So of course, with the derivative, the power rule, we do 3 times 2, and we get 6x. We reduce this power by 1, so that's 6x squared. The derivative of a constant is nothing, so we get 6x squared. And that is what we started with. So now we are ready to get started. We will kick it up one notch from that example by giving you problems that you have to rewrite first a little bit. So this integral would be the same as having x to the 1/3 power dx. So we can still use the power rule of integration. We're going to add 1 to the exponent. So adding 1 to a fraction, in this case, it's like adding 3/3. So that is going to give us x to the 4/3 power. And then we must divide by the new exponent. So we then divide by 4/3. Dividing by a fraction is the same thing as multiplying by the reciprocal. So we're going to go ahead and instead of dividing by 4/3, we're going to multiply by 3/4. So anytime your exponent is a fraction, expect the reciprocal to end up right here. And then here comes the constant of integration. So this is the answer to number 7. All right, how about number 8? We need to rewrite this as well. So that's a horrible integration symbol. This would be the same thing as having 1/4 times, well, okay, so let me break it into 2 steps here. You can agree that having 1/4 times 1/x squared would be the same as what we have. But then, of course, you will understand that 1/x squared is the same thing as x to the -2 power. So this is the form that we want to use. All right, this is really bothering me. All right, I've never been good at drawing these things. Plus, I'm using this digital pen. I'm going to blame the pen. Anyway, so now we can use the power rule of integration. So with the power rule, we're going to add 1 to this exponent. So that's going to give us x to the -1 power, right? Because I'm adding 1 here. So that'll be -1. But then we need to divide by our new exponent. That's just going to turn this negative, dividing by -1. So I'm just going to stick a negative here. And here is my constant of integration. So really this is the answer, but we could simplify this a little bit by writing -1/4x, right? This x to the -1 power just drops that thing down to the denominator, and most of the time you would probably see it written this way. All right, so there's the answer to number 8. What about number 9? Okay, so you can see that 1/x sitting there. So for just a second, I'm going to write 1/x, and then I'm going to write 1/x to the 1/2 power, right? The square root of x is the 1/2 power. you remember that when you are multiplying variables together, you add the exponents. So this is like a 1. So if I add 1 with 1/2, that's going to be 3/2. So this will be the same thing as having the integral of 1 over x to the 3/2 power dx. I think I'll just keep on going off to the side here. So this would be the same thing as having the integral of x to the negative 3/2 power dx. Now we're in good shape to use the power rule of integration. So we're going to add 1 to this exponent. So think plus 3, the denominator is 2. So plus 2/2 is what you're thinking in your mind. So that's going to give us negative 1/2. So now we have, this is equal to x to the negative 1/2 power. But then we divide by the new exponent. But instead of putting negative 1/2 down here, we're going to do the reciprocal. The reciprocal of negative 1/2 is negative 2. And then here comes the constant of integration. So you could leave your answer like this, or you could write it like this with negative 2 over x to the 1/2 power plus c. Or instead of having 1/2 power, you could put this back into a square root. But really, you could stop at any one of these forms and it would be accepted. Let me add one additional statement there in terms of how much do you need to simplify. If you're doing free response, all right, and we're all trying to prepare for the AP exam, if it's a free response question, you can leave it the way I had it at first, or you can write it like this, or you could put it with the 1/2 power down here. Any of that is fine, but what you have to watch out for is those multiple choice questions where your answer has to match. You have to be able to recognize the matching answer among the multiple choice responses that you have. So just be able to simplify, but you don't have to unless you're trying to match a multiple choice question. Anyway, moving on to number 10. So let's rewrite this as the integral of, and I'm just going to square each of these separately because that would be the same thing. So this would be like having 1 over 9x squared, right? And then dx. And this would be the same thing as having the integral of 1/9 times x to the negative 2 power dx. Now we can use that power rule of integration. We will add 1 to this exponent. So that's going to make this negative 1. So now we have x to the negative 1 power. And then we divide by that new exponent. Well, dividing by negative 1 is just going to make this negative 1/9. And that's the answer, as long as we are careful to include the constant of integration. And you're welcome to leave your answer like this, or you might consider writing your answer as negative 1 over 9x plus c. Either is fine, but be wary of the multiple choice. All right, how about problem number 12? Well, we have learned that you can, when you have a sum or a difference like this, you can integrate each term separately. So the integral of 13 is going to be 13x. And then the integral of negative x, well, we're doing that power rule. So we add 1 power to this x, which makes this x squared. And then we divide by the new power, which makes it a 1/2 in the front. And then we put our constant of integration. So this is the answer, and you can just leave it just like this. All right, how about number 16? So we are going to break this up and do each term separately, but I think we will rewrite as we go. So for the first term, we've got x to the 1/2 power. And then in the second term, we can rewrite this. You see the 1/2 right there. But then this second part, the square root of x in the denominator, is like having x to the negative 1/2 power. Okay, does that make sense? All right, you see that this is the 1/2 power, and I just brought it up and made it a negative 1/2. So now we can do the power rule of integration on each term as we go along. So remember, we are adding 1 to this exponent. So if I add 1, that's like I'm adding 2 over 2. So that's going to give me 3 over 2. So I end up with x to the 3 over 2 power. But then I divide by 3 over 2, which is the same thing as multiplying by 2 over 3. We do the reciprocal. We'll do something similar here. We will add 1 to the exponent. So again, I'm adding 2 over 2. So this is going to give me positive 1/2. So I'm going to get x to the 1/2 power, but then I have to divide by 1/2. Well, I already have a 1/2 here in the front, so if I take a 1/2 and I divide by 1/2, these are simply going to cancel each other out. So that's why I'm going to put nothing in the front of here. So in the end, I'm going to put my plus c for the constant of integration. And I would probably just go ahead and leave it like this. Okay, just for the sake of review, I guess, you know that a term like this can be rewritten as the square root of x. Okay, so if you needed to recognize something in a multiple choice question, you would know to look out for that. But don't forget, if you have other fractions like 3 over 2, 3 is the power, 2 is the root. It's always power over root. So this would be the same thing as having the square root of x to the 3rd power. And I would still have my 2 over 3 in front. So I just wanted to review that real quick for multiple choice questions. All right, now let's move on. All right, we're doing great. So problem number 20. Okay, how am I going to rewrite this? So this would be the same thing as the integral of 3x to the negative 7 power dx. So this is very straightforward. So we will add 1 to this exponent, which will make this x to the negative 6 power. And then we divide by negative 6. So that would give us 3 over negative 6. So you could leave it like this, I guess, but most people would probably simplify this down to negative 1/2. And you could either write negative 1/2 x to the negative 6 power, or you might even go ahead and write negative 1 over 2 x to the 6th power. Any of these are fine, and I'm sure you could recognize any of these on a multiple choice question. So there is no chain rule of integration. So our best bet is to expand this binomial. Remember, when you have a binomial squared, you cannot simply square the two terms individually. Instead, you have to multiply 4t squared plus 3 times 4t squared plus 3. So when you do this, you're going to end up with 16t to the 4th power plus, all right, inner I have 12t squared, outer I have another 12t squared, so that's going to be 24t squared plus 9 dt. So now we can go ahead and integrate term by term. So doing the power rule of integration, we add 1 to the exponent here, so we're going to end up with t to the 5th power, and then we divide by that new exponent. So I'm going to end up with 16 fifths. And then similarly here, I'm going to add 1 to this exponent. That's going to be 3. So I have plus t to the third power. But then I divide by that power. 24 divided by 3 is 8. And then integrating a constant is going to add the variable. So I'm going to end up with 9t. And of course, plus c for the constant of integration. So this will be the answer to number 24. Number 24. Okay, how about number 28? Oh, we have a trig function here. So quick review. We have learned in a previous lesson that the derivative of tangent is secant squared. All right, I'm not sure why I wrote my equal sign so weird. So this is something that you should have memorized. So with this in mind, that means, all right, swapping these around, if we integrate secant squared, well, guess what? We're going to get tangent theta plus c. All right, because integration is the inverse of differentiation. So, that's what's about to happen right here. Starting with the first term, though, so we can just do the power rule. So we're going to add 1, and that's going to become theta to the third power. And then we have to divide by 3, so I like to just put a 1/3 in the front for that. But now the secant squared, where there's no chain rule, okay, for integration. So that's why I reminded you of this. We just straight up know that the integral of secant squared is tangent. So that's what's happening. So we're just going to straight up have tangent theta, boom, plus c for the constant of integration. So there you go. All right, I think this is a good place to pause and leave some for the next video. We're going to get into some other stuff here in a minute. So watch the next video if you want to see the next step